Methane digesters. Getting rid of organic waste is a major challenge for the agriculture and waste management industries. By using methane digesters, a large amount and variety of waste can be composted. Things like livestock manure, wastewater solids, food waste, and fats, oils, and greases can be diverted to methane digesting facilities to turn waste into energy and fuel. Anaerobic digestion. Anaerobic digestion is a biological process that naturally occurs when microorganisms break down organic substances in environments with little to no oxygen. Anaerobic digestion happens in swamps, waterlogged soils, deep bodies of water, and even the digestive systems of large animals. The process of anaerobic digestion creates biogas, a mixture of methane and CO2. Now, large facilities can use anaerobic digestion as a way of producing energy. In simple terms, anaerobic digestion is the process of microorganisms breaking down biodegradable materials with the absence of oxygen. The main product at the end of this process is biogas. Biogas can then be used as energy to power homes, farms, and even towns. What is a methane digester? A methane digester is an oxygen-sealed tank. Inside the tank, there is a community of microorganisms. The microorganisms work in 3 stages. The first group is a group of bacteria that break down the biomass. The second is a group that converts into CO2 and other gases. The third, methane-producing bacteria, produce the products from step 2 into methane and CO2. A methane digester is a system used to turn manure, food waste, and other organic wastes into energy. The methane digester produces energy from anaerobic digestion. Here is a photo of a biogas digester. It shows the digester cover, the manure inlet, the outlet, the biogas meter, and the active solids and the complex substrates. Methane digesters. Why? With a growing population, there is more waste created. Human waste, food waste, and animal waste. All of the waste must have a place to go. Much of this waste is added to the greenhouse gas emissions. By using methane digesters, the current waste can be lessened, and the waste can be turned into a great source of renewable energy. Methane digesters also have many environmental benefits. Methane digesters turn manure into energy. Methane digesters can improve air quality and reduce greenhouse gases. Methane digesters also help to protect water quality by reducing the chance of pathogens entering waterways. Here is a photo of the biodigester. It shows the cycle that the biodigester follows. The animal consumes food and produces waste. The waste from the animal is then put into the biodigester. The biodigester goes through its 3-step cycle and produces energy. The solids that are left over can be used as fertilizers. The fertilizers are put onto crops and help them grow. The crops are then fed to the animals and the cycle starts again. Methane digesters in agriculture. This photo shows the methane digesters in the USA alone. This shows dairy as red, hog as green, poultry as purple, beef as blue, and mixed farms as gray. The size of the dot shows the population feeding the digester. The larger the dot, the larger the farm. There are many on-farm benefits to having a methane digester. Energy from the methane digesters can be used to power the farm and even heat the farm. The methane digester helps make the farm be able to manage manure easier and enables animal bedding to be used. The methane digesters also help reduce odor and the amount of flies around the farm. Here is a short video from MSU on their methane digester.
The South Campus Anaerobic Digester at Michigan State University aims to reduce odor emissions from manure, food waste, and biosolids, create a closed cycle for recycling organic material, and nutrient-rich organic materials, and other organic material from campus and the greater Lansing area. Once delivered, the food waste and biosolids will be heated at 160 degrees Fahrenheit for 1 hour to eliminate any potential pathogens. The material will then be mixed with manure from the MSU Dairy Teaching and Research Center and pumped into the digester. The anaerobic digester is a sealed, airtight tank which can hold 300,000 gallons. Organic material will be heated to 100 degrees Fahrenheit and will remain in the digester for 20 to 30 days. Inside the tank, mixers in the digester evenly distribute microorganisms. These microorganisms break down the mixture, producing biogas and nutrient-rich digestate. Biogas, which is roughly 60% methane, is a form of renewable energy which will be used to generate electricity. The system will generate enough electricity to offset the MSU Dairy Teaching and Research Center, around 300 kilowatts per hour, with enough left over to help power MSU. The capturing and use of biogas will generate energy, shrink the carbon footprint of campus, and improve sustainability. What's left in the process is digestate, the nutrient-rich mixture that will be held in the final storage tank until it can be utilized. Mixers in the storage tank will minimize settling for the potential 2.7 million gallons of digestate. Any unused biogas can also be stored in the sealed headspace. The nutrient-rich digestate will be used to fertilize croplands or other biological treatment processes to fuel research opportunities. By utilizing anaerobic digestion technology, the organic materials from MSU will become resources. Renewable energy is created while odors are reduced and emissions are eliminated. This project is one example of how Michigan State University is actively working to improve sustainability.
My personal opinion on biodigesters. I believe that technologies of methane digesters is a technology that will help with the advancement of agriculture industries, energy sources and production, waste treatment, and will have many other benefits for the environment. There are many industries that methane digesters can help with. The methane digester is a technology that will help keep our environment healthy and thriving.